So I'm going to continue on with our master control unit for our Viper jet here. I did this little drawing of the starting system. So you have current over time. Okay, so when you first initially start, current's going to go up to about here, and then voltage is going to decay down through the start till the start's over. And most generally, like we said on the phone the other day, you said it's about 30-second start. So, you know, from this point to that point, it's about 30 seconds. Okay. Now, from here to about here, the voltage is going to decay down to a certain point and then trip and go into boost. And then come on down and then end of start here. That's the unique thing about the fast start, the boost start, you know. Starts it faster. So, you know, you cut your start time pretty much in half if it works properly. So you can go from a 30-second start to a 15-second start. You know, that's in a perfect world, but, you know, you just got to test it and find out. So I'm going to stop the video here and show you our setup. Okay, picking back up here on the video. I've installed this shunt, and that's going to tell me how much current is going out to the starter generator and how much current's coming in to the batteries. In the last video, I had shunts on the batteries. I took those off, and I just put this one massive shunt on. That's going to tell me pretty much everything I need to know. And I have that wired to our data acquisition system. So I'm going to get that set up for the test, and that's going to tell us our starting current and our current, recharging current to the batteries. Also for the test, I hooked this guy up. This is going to act as my ground power. This big old battery right here. I got that hooked up right here. So it's there if I need it. So I'm going to pause the video right here and talk to you about that. Okay, so like I said, we have ground power and we have boost and we have batteries. You do not have to use the boost feature. It's there if you want it. You can just do a normal parallel start. Batteries only, no boost. And you can do a ground power start. If you do a ground power start with boost, your ground power will come in to about right here, and then it gets locked out and goes into boost. So you'll have ground power support up to this point. After that point, ground power is locked out of the system. It's, you know, it'll isolate itself, go into boost and start. Now, if you don't hit the boost switch, you'll just have a normal regular start. So just batteries only, paralleling, no boosted start. Okay. So I'm gonna pause the video here, and we're gonna start this thing. Okay. So we're going again. Got my data system up and going. I got a stopwatch here. That's gonna give me some kind of estimate of how long we've been spinning the starter generator. So our batteries are at 25.4 volts, and our ground power battery is at 25.9 if we need it. If I turn on the ground power battery, it's going to go parallel with the batteries, so it'll read the same voltage. So here we go. We're going to turn on ground power. Yep. Tied together, paralleling. Okay, so, but we're not going to use that right now. We're just going to use these batteries, parallel series. Okay, and hopefully we get a good start, or, you know, good distance. So I'm going to start the timer, and I will hit the start switch in 10 seconds. So here we go. Got to be watching the current too, so I know how much current, how many amps. Now. Okay, so I believe so it could have kept going, but I was really making this machine spin. All right. Well, now I got to do a little bit of math calculating to see how much current was going through that shunt to the starter generator. So, and our battery is now set at 24 volts, 24.8, 24.9. Okay, let me do a quick math calculation to tell you how much current we sent to the starter generator. Okay, so I'm going to pause the video here and get back with you.